All right, we're picking up with example 2 out of Unit 5, Lesson 2, on distributions of data. We're looking at the key concept for box and whisker plots from distributions. So these box and whisker plots are basically the exact same thing that we've already seen in example 1 for the skewed distributions on histograms. A negatively skewed box plot is going to have a longer side to the left. You can see the whisker over here is longer, the part of the box is longer. The longer side is the direction of the skew. So this is left skewed or negatively skewed. This one is right skewed or positively skewed. And this one is symmetric. Going into example 2, this is about wages. It says the hourly wages for a random sample of employees of a restaurant are shown in the table. Use a graphing calculator to create a box and whisker plot, and then describe the shape of the distribution. So we're going to pull up the calculator again. We're going to go back into Stat, Edit. Again, we're going to clear our data. We're going to go up to the top to list 1, hit Clear, and then the down arrow. And then we're going to pull in our data. So we've got 1050. Let me shrink this down again, so I can see the data without having to jump back and forth too much. All right, so start off 1050, 750, $8, 750. Next column 775, 11, 25, 750, 10. Next column 825, 725. 675, 725, next column 950, 650, 725, $8. Last column 650, 825, $9, and $9 again. Okay, bringing calculator back into the full screen. You can notice here I never typed, like for 650 I didn't type 6.50, I can just type 6.5. It's the same thing, it just saves you a couple seconds here and there. Back over here we're going to now advance and create a box and whisker plot. So the way we're going to do that here is we're going to go up to second y equals, go back into our plot menu. We want to make sure again that it's on. This time our type, instead of using box plots, we're going to use, instead of using histogram right here in the middle, we're going to use a box plot. This box plot right here, these two are both box plots, but this one shows outliers if we have them, which are data points that are really far away from the others. And I like to use this one. Sometimes you specifically have to use this one, and sometimes you can just get away with using the other one. This one doesn't show the outliers if there are outliers. But right now we're going to use this one over here on the right side. So we're going to scroll over. Once that's flashing, we're going to hit Enter. Again, we need to make sure it says List 1. Then we are going to go up and look at Zoom 9, which is our Zoom stat. It goes to the window wherever your data is. So this is the box and whisker plot that we see. If we look over here, we can compare it to this. Looks pretty similar. Let's just make sure that we have the same window that they're using. For the x values, they're going from 6 to 13 by 1s and 0 to 8 on the y's by 1s. So I'm going to come back over here, go to my window. I'm going to go from 6 to 13 by 1s, 0 to 8 by 1s. Okay, let's go look back at the graph. Now this box plot should look exactly like that box plot. And you can see they're basically the same thing. So we need to talk about which direction this is now. So you see that this has a longer side to the right. That means it's skewed to the right. It's skewed positively. Part B. The hourly wages for a random sample of employees of a restaurant are shown in the table. Describe the center and the spread of the data using either the mean and the standard deviation or the 5-number summary. So again, because this data is skewed, we're going to need to use the 5-number summary. So to get to our 5-number summary, we're going to go back to the Stat button, go over to Calculate, the one-variable statistics. Again, we're pulling from list 1. We can just go down and hit Calculate. And our 5-number summary is going to be the minimum 6.5, Q1 725, median 7.875, Q3 is 9, and the max is 1125. And again, the reason that we are using the 5-number summary is because the distribution is skewed and not symmetric. Okay, here's a check your progress problem. Go ahead and pause the video, read through the scenario, dump the data in the calculator. When you have your answer, go ahead and advance to the next screen. All right, our answer for the check your progress is B. This one was skewed. The median is 3. The range goes from 0 to 12. The first quartile is 1. The third quartile is 7. All right, for example 3, we're going to compare data using histograms. Part A is about games. It says Tyler and Jordan are working through several brain teasers on the computer. The time in minutes that it took to complete each game is shown. Use a graphing calculator to create a histogram for each data set and then describe the shape of each distribution. All right, so I'm going to pause the video and type all my data in, and then I'm going to resume the video once I have it all, so I don't waste a whole bunch of time in the recording. All right, you can see I've got all my data in now. I put all of Tyler's time in list 1, and I put all of Jordan's time in list 2. Resume the size on my calculator. I'll come back over here. We're going to create a histogram for each data set. So these are the histograms that we're hoping that we can create. What I'm going to do is show each of them to you separately, and then I'm going to show you what they look like if I try to do them on the same screen, just to see that it's too confusing to do them both at the same time. Our window, we're going to go from 1 to 8 on the x's and 0 to 8 on the y's, and each of them we're counting by points. All right, so to get into the stat plots to turn histograms on, you're going to go second, y equals, plot 1. We will make sure it's on. We're going to come down here, go back to the histogram, which is the third choice. We want to use list 1. That's for Tyler's times. We're going to go to window. We're going from 1 to 8 on the x's, 0 to 8 on the y's, and we can hit graph. This histogram looks identical to this histogram. Now we're going to go back to stat plots, second y equals again. We're going to go in and turn this one off. Go up to the plots. We're going to go over to plot 2. Select that. We're going to turn this one on. We're going to go down to the histogram, select that. And this time we're going to go from list 2 as our list, so we can get Jordan's time. So we're going to hit second, 2. Now it's list 2. Our window still stays the same. Hit graph, and you can see this histogram is identical to this histogram. Now just for comparison's sake, I'm going to go back to my stat plots and turn both of them on at the same time, just to show you what they look like. You can see this is very confusing. It's hard to tell what's going on. It's slightly helpful that I have 2 different colors, but if you have a version of the calculator that doesn't have 2 different colors available, you don't have the color edition, this is going to be nonsense to you, so you don't ever really want to do both graphs on at the same time. You just want to look at each of them individually. So you can see Tyler's graph, if you were to put a curve over this, would be slightly skewed on the positive end. The tail would be over here on the right, whereas Jordan's data, it's very symmetric. It's the highest is in the middle, and then each of them slope down as you go to each side in the same pattern. Part B says that we need to compare the distributions using either the mean and the standard deviation or the 5-number summaries. So we know Tyler's data was skewed, so we're going to use the 5-number summary for Tyler, but Jordan's data was symmetric, so we're going to use the mean and the standard deviation. for Jordan. So we're going to come back over here. We're going to go stat, calculate, one variable statistics. First kid was Tyler. Tyler was skewed. So we're going to use list 1 for Tyler. Skewed means we need the 5-number summary. So we're going to use 2.8 for the minimum, 3.45 Q1, 4.35 for the median, 5.15 for Q3, and 6.1 for the max. Let's look over here and see that they have the same answer as us. 4.35, 3.45, 5.15. And then for Jordan, because Jordan was symmetric, we're going to go back to stat, calc. This time Jordan's data was in list 2, so we need second 2. We're going to calculate, enter. This time we use the mean, 4.5, and the standard deviation, 1.097. It says here that Jordan's times occur, the middle 50% are between 3.75 and 5.4. What you would need to do to get that is take the median right here, 4.5, and add the standard deviation, and then take the median and subtract the standard deviation. And that would give you the 3.75 to the 5.4. Here's a check your progress for example 3. Go ahead and pause the video. It's going to take you a while to type in your data. Once you have all the data and you've calculated stuff, go ahead and resume the video. We'll see the answer on the next slide. Okay, our answer for example 3 is choice B. The second period class had a higher mean and a larger standard deviation. And the first period was a little bit more consistent, meaning that it was probably closer to being symmetric than second period. All right, again, we're going to pause, pick up with the next example in the next video.